There we go. So welcome everybody. This is the April 2023 evening program of Los Angeles Audubon Society. My name is Travis Longcore. I'm president of LA Audubon, and we have our special guest Patrick Donnelly with us tonight. Wanted to let everybody know that if you learned about this through, say, social media and you'd like to get emails of our announcements, you can go to our website, laaudubon.org, and there's a button on the bottom of just about every page to sign up and get these announcements sent to you. And also the rare bird alert, that's weekly. You can sign up for our newsletter, the Western Tanager, and also on the website, if you're so inclined and want to support free events like this that educate the public about birds and bird conservation, you can of course join LA Audubon, and there's a button in the upper right hand side to join or renew if you're a member. And I do see a few members here tonight and want to thank you of course for your long-term support of the chapter. So our speaker tonight is Patrick Donnelly. He is both a U.S. Fish and Wildlife Service research scientist in the Migratory Bird Program and a Ph.D. student in the Wildlife Biology Program at the University of Montana, and has been doing some really interesting work on waterbird conservation focused on climate change and its effects on our environment and waterbird habitat, and understanding the sort of continental networks of wetlands that are emerging as potential problem areas for avian migration in Western North America as the climate changes. And of course, the climate is also very variable, as we've learned here this year in the Western United States. So I want to welcome everybody. The chat is there. I'll monitor there for questions and let Patrick know about them as they go along. And also, if you happen to be watching on Facebook Live, you can put your questions and comments, and I'll keep an eye out over there and bring them over to the meeting so that we can respond to them as well. So with that, and also with the hope of everyone supporting this research as well, I want to introduce and welcome Patrick Donnelly.
Thank you, Travis. It's been really cool this last month or so. I've been kind of virtually skipping around the West, talking to different Audubon chapters about this research and garnering support. And I always learn, I think, as much from talking to chapters, perhaps as you guys learn from me. So tonight, when we're going through some of these kind of overviews of the science we're producing, you guys feel free, raise your hand, put questions in the chat, and we'll kind of address those. We'll also, I think, have some time near the end to talk about some of those things too. So again, just nice to be here, and we're gonna make it pretty casual. I'm gonna share a screen right now and go into slideshow mode. I'm gonna put you guys where I can see you over here. Some rearranging. Make you bigger. And if you guys feel comfortable too, one thing I learned from the pandemic, I'm also a professor, I teach a lot online. If anyone does feel comfortable turning their cameras on while I'm talking, no judgment if you guys are eating dinner, if you're watching television, babysitting kids. Sometimes it's just nice to see faces, interact with folks, and I appreciate it. If you don't want to, that's fine too, but I always kind of make that request because I like to see people and talk to people, and that's kind of what tonight's all about, is connecting with you guys. So much appreciated if you do. Move the slideshow going. And like Travis talked about, tonight we're going to discuss how climate change is influencing migratory birds, water birds, across Western North America. And you might ask the question, well, how is a guy sitting in his basement in Missoula, Montana, relative to Los Angeles Audubon? How are those connections made? And of course, this is a slide of white-faced ibis we'll talk about later on, which is actually the project we'll be highlighting. But I just want to give you guys a quick look at some of the research that we do and how we're connected as people through birds and wildlife. And this is one for snow geese. there's a large population of snow geese a little ways north of you guys, 4 or 5 hours north in the Sacramento Valley. But colleagues and I, the USGS, we've been putting satellite markers on these birds for a number of years now. And all those green lines you see across the US and into Canada and up into Alaska and the Arctic and even into Russia are individual birds and migrations moving from the Sacramento Valley where those birds winter. And the birds that have been in California this whole winter, the last 2 weeks have been flying over my house. Okay, so they've been in California. There actually is a big soccer field about 2 miles from my house. I run around that all the time. There were about a dozen snow geese in that field 2 weeks ago. We had some weather. Those birds set down. And sometimes they hang out in Missoula before they hop up to the prairie pothole area up here. There's a place called Freeze Out Lake. And then all those birds, there's 2 places they go once they get to Canada. Here, this is the northern prairies. They go to Banks Island, here up in the Arctic in Canada, or they fly all the way across here almost nonstop from down here to Wrangel Island off the screen, which is actually in Russia, in the Chukchi Sea. And those are where all those birds go. So if you ever do spend time in the Sacramento Valley, you know those birds are wintering in the high Arctic, and those are the 2 places they actually come from. And we're connected because those birds come over Missoula, they go to the Arctic, they come back, and they winter in California. So this is the connectivity we see with birds and understanding that we think about flyways, and I know I'm talking to the Audubon group, and you guys are pretty savvy about these things, is flyways are those freeways in the sky that connect migration. And that migration route we saw from Real Birds Are Marked kind of simulates this cartoon version of how birds move across these systems. But if we think about how birds do that, they move because there's resources or food in places, different times of the year, frozen water, not frozen water, environmental factors that drive them to make decisions to optimize their kind of biological resources. That's why they go to the Arctic to raise their chicks, because they can nest on the ground. They have a lot of resources when things get warm. Chicks grow up fast and they can fly back down to California to winter. But as these birds move across these landscapes, they're exposed to different ecological conditions. Climate change is really kind of shifting the dice and rolling things around different ways we don't quite understand. And so what that does is it exposes birds to multiple risks across the flyway. We have things happening in the Arctic that can influence birds. We have things happening in the Sacramento Valley influencing birds. And until now, it's been a real challenge to understand all these things together because they're happening in such disparate places. We don't have the technology and everything to really understand what's happening everywhere. So we have to think really hard about how we do that. And some birds have been really good about adapting to change, but we call that plasticity, how they can stretch their environments and the way they adapt in their ecology. But sometimes things are changing so fast that plasticity gets overstretched, and then when it gets overstretched, populations decline, things happen that are bad. And what also happens is things like what I see here on number 3 is called cross-seasonal effects. And you might ask, well, what is a cross-seasonal effect? Well, what a cross-seasonal effect is in the context of this discussion is, say, a goose in California, it's a dry year, it can't eat enough food. So what these geese do typically is they take their calories with them to the Arctic, because when they get to the Arctic, everything is still frozen. What the birds do is they get there early so they can defend their territories. And there's some period of time which they don't have enough food to eat, but that fat sustains them until that time happens. And that peak food abundance occurs when those chicks hatch. And so if a bird in California doesn't get enough to eat, it can affect its nest success all the way in the Arctic. And so these are those connections across the entire flyway that are so important to kind of connect the dots with, and why we think about flyways in really different ways. And so I just want to put that into context for you guys. To kind of set the stage for how these things work, I'm going to take you guys on a little tour around the flyway. And we're going to start in California. We're going to start with our Arctic goose, where it came from. And you can see the map up here. This is the gray, kind of grayed out dark area, the Central Valley. And actually, this is the Sacramento Valley. This is rice country, if you guys have ever spent time around Sacramento and north of there. And this is a grower walking on a ditch, and you can see on both sides this area is flooded. This is May. If you're in Sacramento country in May, you see a lot of water across the landscape. There's about 580,000 acres of it, actually. And you can see the rice here and these little green kind of things coming up, emerging out of the water. That's the rice growing up early on in late May, early June. And this provides a lot of habitat resource for breeding shorebirds. Things like black-necked stilts and avocets will breed on these dikes. And it's an important thing, but what's really important is it happens later on in the year. And once the rice matures, they drain the fields and they cut the rice, they bale some of the straw, and up until about the 90s, they used to burn off all the rice. This rice stubble that's left over, if you walk through it with your shoes, it can really tear up your boots and your pants. It's pretty tough stuff, so burning it was a nice solution to get rid of that. Well, the Clean Air Act came along and said, well, we're not going to burn rice anymore. We have to do something else with it instead of. So what they do now is they flood the fields. They flood the fields like they do in the springtime to decompose all the rice stubble without burning it. And that creates about 370,000 acres of agriculturally supported wetlands in the valley, which supports 2/3 of the Pacific Flyway. That flyway I just showed you guys earlier, this guy here, 2/3 of all the ducks that breed up here winter in the Sacramento Valley, and most of them are feeding on the rice that gets flooded and looks like this. So these are rice fields. This is north of Williams, kind of east of Colusa, or west of Colusa, if you know your geography in the Central Valley. Interstate 5 is kind of back over here on the horizon. And these rice fields get flooded, and they create this huge food resource because there's still grain left in the field, because they don't get all the rice out when they harvest it. There's some left over. And then it starts to grow invertebrates, little bugs that actually get inside that rice. And all these birds can utilize it. And if you look close, you can see these white kind of patches here. This is about 19,000. This one over here is about 24,000. This one's about 12,000 snow geese. So these are big accumulations of snow geese. They actually roost on national wildlife refuges like Sacramento, Delavan, Colusa. There's a state wildlife refuge called Gray Lodge, not too far from here. And they go out to these fields and they feed. So there's this kind of symbiotic relationship between wildlife refuges and agriculture, which have replaced a lot of the natural wetland loss in the Sacramento Valley. And it's a great thing. We can feed people, we can feed birds. And you can see here, if you look closely inside these big rice kind of paddies, all the water is brown. That's because these geese and ducks get in there and they just rototill that stuff up. And you drive by in the morning, the ducks are usually nocturnal. They all fly back to the refuge, but when you come back in the morning, all you see is duck and goose feathers in this muddy water because all night they've been out there feeding and picking up all that rice. And so this is a really important part of that puzzle which glues the kind of Pacific Flyway together. Another important thing to think about when we think about how we connect birds, a lot of birds that actually winter in the Sacramento Valley, they go through places like the Great Salt Lake. These are closed basin watersheds. What that means is all the water that comes in the watershed, that drains down to one central lake and never leaves the basin. And so places like Great Salt Lake and Northern California, places like Goose Lake, Summer Lake, Lake Abert, these are all internationally and hemispherically important sites for migratory shorebirds and other waterbirds. And you can see here the large flock of shorebirds on the Great Salt Lake. And the cool thing about the Great Salt Lake, it's water chemistry. Salt water grows food for migratory shorebirds. And you can see here, the food that's being grown is actually brine flies and brine shrimp. And these brine flies are hatching out as larvae and on the surface of the water. And this is actually, you can't tell now because it's in its winter phase of coloring. This is actually a Wilson's phalarope. And that phalarope is skimming that water, picking up all those brine flies. And those saline lakes are incredibly productive in producing these resources. And you guys know the story about Great Salt Lake drying up, right? I mean, this is a big part of our research is keeping water in the Great Salt Lake. And I don't know if you guys know, I'll connect this to Los Angeles and Mulholland and all the engineering that took water from Owens Lake, which is another saline lake system in the Great Basin, to water Los Angeles. Well, when they drained Owens Lake, it became the largest air pollution site in the entire continent. There was more air pollution coming off of Owens Lake than any other site across North America. Basically, you get dust coming off the eastern Sierras, picking up all what is it's selenium, which is toxic. And so everyone living downwind of Owens Lake started getting cancer. So Metropolitan Water District got sued. They spent $8 billion now putting gravel and more water back on Owens Lake to reduce the cancer rates occurring downwind and reduce the pollution. But now think about not just Owens Lake, but 20 other lakes around the Great Basin drying up. We're talking about birds, but what birds can do is save people, because all that toxic dust coming off those lakes in places like Great Salt Lake, big metropolitan area only miles away from that toxic dust source, are things we're worrying about today in climate change. Birds help us solve that. Keeping water on the lake keeps birds fed and keeps people healthy by keeping dust underneath the water, not in the air. Really important to think about in the context of how shorebirds can be really a catalyst for keeping things healthy. A little bit of Mexico. If you've not spent time in the highlands of Mexico, I used to spend a lot of time there. It's a little dangerous to go now, but I just want to give you guys a little tour of Mexico too, because there's these closed basin lakes in Mexico as well. They're freshwater lakes. They're not saline, but the people, the agriculture, the ecological systems down there are incredible. And these are places in northern kind of the highlands, these kind of specks up here. One of them is actually in the U.S. called Wilcox Playa. But this is Los Mexicanos, and this is Bustillos, which is their lake in the background here. Rural agricultural systems in the foothills of Sierra Madre. We get a lot of birds that winter in these sites as well. A lot of white-faced ibis we'll talk about later actually go through these sites. If we move a little further south, this is a little speck right here. This is a basin called Santa Quilo. It's in the state of Durango. And I bring this up because I like to tell a story. We had a GPS, a satellite GPS marked bird from California. It was a white-fronted goose. And we had a long-billed curlew that was marked in Montana, and a white-faced ibis marked in Idaho. And they're all about a quarter mile of each other, sitting on the same wetland in Santa Quilo. And so it tells us how uniting some of these wetlands are in Mexico. You have birds coming from across the continent, passing through the Central Valley, going through the Salton Sea, and ending up in places like this, which are critically important as wintering habitat across these areas too. One more stop we'll take is this last big blob down here in Michoacan, which is one of the largest lakes in Mexico, called the Quitzo. And this is another area too where we get large concentrations of water birds. When I say water birds, I'm talking about waterfowl, shorebirds, and wading birds all together. And again, this is a terminus for white-faced ibis, cinnamon teal, you name it. Birds use Mexico as well, but we need to think about all these systems together and how they're all responding. So I just want to give you guys some context for the diversity of how these systems are, the people behind them, the ecosystems are all really, really special places. Birds just connect it all for us. Switching to climate change, I was in high school when Dr. James Hansen, director of NASA Goddard Space Center, testified in front of Congress, talking about climate change in the late 80s. And he was ringing the bell 40 years ago about how climate change can influence, how ecosystems respond, how economies respond, how we need to think about things, and what we need to start doing today to make those changes. Every prediction he's made in this congressional testimony has either come to fruition or we've bypassed it as far as temperature and the effects of climate change. You can see in the background here, this is the Mauna Loa data set. It's a famous data set of CO2 measured in the atmosphere. And it goes up and down between winter and summer. But look at the trend. It's just going up and up and up and up and up and up. That is what we're doing in the atmosphere. And this is what's affecting migratory birds. It's affecting us as people. You guys are experiencing that in California this year with atmospheric rivers, with historical drought. This is something that affects everything, not just birds. And it started in 1989. And I'd like to show this slide before we get more into detail of some of the stuff I'm doing to give you guys a sense of, people ask, well, what does climate change really do to birds? We're going to talk about wetlands, but I'm going to talk about wildfires for a second before we talk about this, because this is something people don't connect with birds. And let me explain what you're looking at here in just a second. These blue tracks in panel A, these are what white-fronted geese look like when they're migrating from central Alaska. They all breed in central Alaska. This is the Thule goose population. It's a subspecies of greater white-fronted goose. This is what they look like. They're really, really cool birds. They all winter in Delavan National Wildlife Refuge. in Central Valley or in Sacramento Valley. And before they stop at a place called Summer Lake in Oregon. So the blue tracks, what they normally do, they fly down here to Summer Lake, they hang out for a while, eat some food, and they bop down here to the Central Valley. And you can see here in this year, there's some little kind of red streaks and some white. These are actually small wildfires. Nothing to be concerned about, pretty small in a typical year. But if we look at this in 2020, you guys experienced a lot of smoke in California. I don't know how much you guys experienced in LA that year, but up in Sacramento and Montana and Oregon and Washington, we got pummeled by smoke for months and months and months. Well, this is what happens when geese intersect smoke. Those lines that typically go right to Summer Lake, all of a sudden those birds are flying above smoke plumes around all over the place, ending up over here in the Idaho-Washington border. We are finding dead geese in the middle of the Great Basin that essentially have starved to death. They've used up all their fat resources, and all their muscles are atrophied because they've spent so much time avoiding smoke as they're trying to get to their migration stopover sites. Because when they leave Alaska, they've got their fuel tanks kind of tipped off, but if they go too far and run out of fuel, bad things can happen. And so this is what smoke can do. This is what climate change can do to migration. It's really something I want to point out that's not always in the front of people's minds, but things like this is really important to think about too. But let's transition to something more directly related to wetlands. And this is a picture of an American coot that didn't make it. The reason this coot didn't make it, it was up in the Klamath National Wildlife Refuge. And late summer, a lot of birds from California fly up to Northern California and Southern Oregon, and they molt all their feathers. Waterfowl and coots are what they call catastrophic molters. They lose the ability to fly as they're molting for about 30 to 45 days, and they land on these big semi-permanent wetlands out there, and they go around and they avoid predators by diving into water and going into cattails. See the cattails in the background here? See that kind of white line? That's where the water used to be under normal conditions. And because all these wetlands are drying up, we're concentrating more birds in smaller areas with warmer water, and things like botulism are breaking out. And this year we picked up 60,000 dead birds in 2 weeks on Klamath Refuge. And you can see here, this is a blood quill. This is a feather that's developing, which would have been a flight feather, because this coot was molting on this large wetland with too many birds, disease outbreak, and things happen. This is another effect of climate change, what I call our climate change tax on wildlife that affects these populations. So just want to point that, that's the story behind it. Well, I asked the question, well, what do we do about it? What's changing so fast we can't control? So I published a paper in 2020, and we looked across these important wetland landscapes, and we measured all the wetlands. And what we measured was the wetlands were still there, but the water was not. About half the water on these wetlands is gone compared to what was there only in 2020. Things are warmer, things evaporate faster, the wetland's still there, but the water those birds need to survive is gone. And that's what's happening in the western US. But when we looked at Mexico, the opposite's happening. It's getting wetter. That's this weird thing with climate where you can't predict the way these things are going. In the US, snowpack is evaporating faster. There's less water coming out of the Sierras and places like that. So the wetlands aren't getting as wet. But in Mexico, there is no snowpack. It's monsoonal rains. It's thunderstorms. When atmosphere are warmer, it holds more water, and wetlands fill up faster. And so places like Mexico in the future are where we need to invest more money, because we think as birds migrate and adapt to drying in parts of the Intermountain West and the coast of California, Mexico will be that place they can go to find those resources. To just give you guys an example of what real change means, and I think Travis sent out a link to a tool that we like to use. I don't just look at birds, but actually I'm a coder and build models too using satellite imagery. And in panel A here, all the blue, this is all flooded rice fields in December of just last year, just a couple months ago. And you can see the blue here on the west side of the valley. These are wildlife refuges that flood their wetlands using ditch water and things. They have rights to water, they can flood it. So they're kind of doing agriculture for wildlife. What it's supposed to look like is in panel B. Typically in a normal year, this is what it normally looks like. But this is what happened between A and B in only a week and a half time. through atmospheric rivers. So this was the dry condition that should have looked like this, but it looked like this 2 weeks later because atmospheric rivers slammed into California and 200,000 acres of wetland filled up in 7 days. This is the dynamism, just like the smoke I showed you earlier, that are impacting water birds. We call it whiplash climate events. You go from extreme drought to extreme wet, and we need to understand how birds respond to these systems in real time and space so we can deliver conservation that's meaningful to protect those resources, or at least have measures in place to take advantage of them when these things occur. And so we're building models that put this on people's desktops so they can tell stories about how climate's influencing birds as well. To link birds and climate back to the environment, we're using something called eBird. And I'm talking to a bunch of Audubon members, so I'm assuming you guys are all avid eBird fans. And you guys upload your data when you go birding into eBird. It goes up to the Cornell University. And we go back and take that data and we reconstruct how birds move across the continent with it. And we link it back to those wetland pictures I just showed you, the Sacramento Valley of rice and wetlands flooding. So we can determine how climate change is influencing where birds go and how they react. And so here's what we did. We took a bunch of eBird data, and we took all the wetland data, and there's different kinds of wetlands. There's wetlands that are semi-permanent wetlands. They typically never go dry. And these are places like where that coot died. These are semi-permanent wetlands. They go there to kind of molt. Birds like mallards and other dabbling ducks raise their broods on those sites. Ibis build their nest there. But then some of these other species, they use more shallower wetlands that dry up during different times of the year. We call these seasonal and temporary wetlands. And they forage in these sites. Some of them build nests there too. But we want to understand how these different types of wetlands are responding to climate change, because depending on how they respond, it could affect species in different ways. And so eBird gave us kind of that way to determine where species were and how wetlands are responding, and we got this. As things got warmer, temporary wetlands, which are very shallow and only wet for a certain period of time, very short period of time, they dried up altogether. They went away. Seasonal wetlands weren't wet quite as long, and they function like temporary wetlands. So they were shallower and only wet for a short period of time. And semi-permanent wetlands, well, they weren't semi-permanent anymore. They were seasonal. They were shallow, and they'd dry up like in 4 or 5 months. So what happened is, if you were a bird that needs semi-permanent wetlands, climate change, we found, is disproportionately affecting you in ways that it wouldn't affect birds that rely on these other types of wetland habitats. So this is how climate change is disproportionately impacting certain species. And for us, it lets us target conservation efforts that focus on semi-permanent wetland conservation, because that's what's most impacted across landscapes. So how do we take things that are even more detailed than eBird? Because when you get an eBird data set, it's millions of points, but we don't really get a really good idea of exactly where that bird is or how they move. So what I end up doing a lot, part of my job, other than building these tools, we look at wetlands, is I capture birds and I put GPS tags on, like I gave you that example of the snow goose. And that was some work my colleagues are doing. The work I do mostly is on sandhill cranes and white-faced ibis. And so this is a colleague of mine, Dan Collins. He's distracting the sandhill crane that's under a rocket net. We take cranes, we bait them in with they like to eat corn. So on the wintering grounds, they walk into an area, and we use kind of rockets, and we shoot a net over them. Goes over them, comes down. And then we have to do what like Dan's doing here, is go in and carefully remove the bird from the net. And cranes are pretty mean. You have to be really careful. They'll stick your bill right in your face. So you have to kind of grab their legs, and Dan's distracting with his hand. He's going to go and grab their legs. You can hold their neck. Once you have their neck, they're in pretty good shape. And then we attach a GPS tracking device on their leg. And it's a solar panel, and this device talks to satellites, so it knows where the bird is, and then we get the data back. And all these points you're seeing here are all from birds marked down here in New Mexico and southern Arizona and the Salton Sea, not far from Los Angeles. And they fly up and migrate to the breeding grounds. We have one that actually breeds up here in Alberta now too. And we track their movement through time and space. And what these birds are a really good predictor of things like this. These are wetlands in southwest Montana. These exist in Nevada, places like Colorado, Utah. And these are ranches where they use water to flood irrigate these hay meadows. But there's more and more pressure to keep water in Lake Powell. In places like the Upper Green River where these kind of systems exist, they want to pay farmers to not flood irrigate these fields anymore, but instead just run all the water down the creek and right into Lake Powell. Now, you might say, well, keeping water in the creek's a good thing. Well, it kind of is, but when we spread water out in these floodplains, it fills up this giant sponge of water underneath all the green grass you see. And as things dry out in the summertime, that water migrates underground back to the stream channel and keeps the water cold, keeps it running all year long. So all of your trout, all of your bird species that you water in August, this keeps that stuff going. It's part of what we call ecosystem services. And if you go in and remove that water and put it in Lake Powell, this would look like a desert, essentially. All the green kind of sedges and rushes and willows you see would essentially dry up, and all that resource we have there for wetlands like supporting phalaropes. There's actually a northern pintail sitting on a log back here on the same ranch in the upper Beaverhead in Montana. And this is actually a sandhill crane nest that we followed, a bird we banded in New Mexico. And it was only about 2 hours from my house where it lives in the summertime. So I went in and looked at the nest, and we were monitoring the bird there. They built their nests in these places. So protecting these places is critically important from an agricultural standpoint, but also from a wildlife standpoint as well. And cranes help us do that. But what about things that aren't these ranches across the West? What about things that are these big semi-permanent wetlands like I showed you with the American coot? Well, if you look closely at this picture, what do you see in each of the wetland types? You see a white-faced ibis. White-faced ibis are what we call umbrella species. They use a diversity of habitats. They're kind of like the canary in the coal mine. So if we see ibis responding or populations going down, we know we're losing certain components of that habitat that supports not only ibis, but all the other species around them. So they're the umbrella species, because remember, when things dry out, things like these semi-perms that ibis need to nest on go away. So what we've been doing is using ibis is kind of the same way you use cranes. And this is a picture of an ibis on a wetland in Idaho. And you can see here, this is a blue-winged teal. Just to give you some examples, these are birds that are nesting in the same wetland, actually. You can see some pigweed here, which when this dries out, this will be really good duck food. And this is some juncus they're walking on. They're foraging together. This is an example of white-faced ibis in the wintertime. This is on Kern National Wildlife Refuge, kind of just over the grapevine from you guys in the San Joaquin Valley, where those birds forage in shallow wetlands. And this is an example of birds actually in those big semi-permanent wetlands like the one we showed with the coot. There's a big ibis colony there. They're colonial nesters. They get thousands to hundreds of them that all nest together. They nest in these tall cattails or bulrush, and they have these really cool, you can see right here, these kind of turquoise-colored eggs. They're really cool shapes, too. They're kind of pointy on one side. Just a really cool bird. And so what we're doing with these guys, I had a student, her name is Shay Kuhn. She just graduated last semester. Shay went around to all the ibis colonies in the West where all these dots are. And she determined how these colony wetlands, not only the colony where the wetland where the colony was, but the wetlands surrounding them, those were the dots. It was about 18 kilometers. That's how far they migrate every day to feed. If they're getting wetter or drier. And she found that most were getting drier. That's all the red ones you see here are the ones that are getting drier over time. And so we said, boy, the canary in the coal mine is going to tell us a lot. Shay just told us that most of these sites are drying. We need more data on ibis to collect, to determine where and how we can influence conservation efforts to maintain these systems to support ibis and all the species that kind of surround them. So here's an example of Grays Lake Wildlife Refuge. And this is an example from late summer. Typically, this is wet. This is the Sandhill Crane Survey. I fly a survey that goes across the West each September. We count all the sandhill cranes in the West. And I get to take pictures of these wetlands each time we fly by. This is what the systems look like more recently, last 10 years. You can see here down at the bottom, these cattails are 6 feet tall. Water should be about 4 feet into those cattails. So this is a place that should be hosting trumpeter swans, sandhill cranes, white-faced ibis, and it's being reduced to dust because of warming temperatures. What does that mean for ibis? Well, the cool thing about ibis, and for me, was no one's ever put a GPS on ibis before. We don't know where they go in the wintertime. We have some idea, but we don't know how they're all connected. So we had to figure out ways to catch an ibis. And the best way to catch an ibis, if you haven't thought about it, is actually at night. What we end up doing is getting on airboats or other kind of boats. We go out in the marshes and we use big strobe lights. And if you flash a strobe light on an ibis while it's sitting in the cattails, they just kind of stand there. And we just kind of walk up and put a net over them and we take them off. Sometimes they fly up and they'll land on your head and they'll land right in the boat. And you can just pick them up and grab them. They're really docile. They're really, really fun animals to handle. And what we end up doing is attaching these little satellite transmitters on their back. And there's a solar panel here. And what they do is they collect GPS points, just like you would normally. And each bird that we mark actually has a Verizon cell phone plan, for real. What they do is they collect the GPS points, and those things stay stored inside this little unit there on their back. These things weigh like 9 grams. They're really super light. And when the bird flies by a cell phone tower, it talks to it. And it reads its Verizon plan. It takes all of its data off that little package on the back there, and then sends it to a computer where I can download and look at it and get all the GPS points. And so basically, they fly around collecting GPS points from space and then talking to cell phone towers and downloading all the data from the Yucatan to Montana each year. And this is what it looks like. It's a little backpack. It's a little elastic strap which goes underneath it, and that attaches to the bird on its back here. It's kind of got like a little backpack that goes below its chest, crosses over, and goes behind and from its wings. And they do really, really well. And in 2022, we put out 40 different backpacks across these birds in the West. And this is the data we got. And we were marking birds in southern Oregon, central Oregon, Idaho, and eastern Idaho, and parts of Nevada. And all those birds went down to Great Salt Lake. A bunch of them cruised over to California. They're hanging out in the San Joaquin Valley. A lot of them hang out just south of you guys on the Salton Sea. But some continue down to the Sinaloa coast. And remember that big wetland I talked about, Michoacan, in Quito? They're all hanging out in Quito down here, just north of Mexico City in the southern highlands. One's gone down in the Yucatan. We had one I don't have on here that's hanging out in Baton Rouge, eating Cajun food. It's going to come back, we think, sometime to breed in Idaho. But we're just discovering how these birds are interacting with landscapes. And here's a detailed view of a big wetland. This is like a big semi-permanent wetland like the one the coot was on. Their nest colony is right here, and each day they're flying out to these ag fields where they're doing irrigation. When they irrigate, they produce food or food resources so that the birds can probe into the soil because it's nice and soft. They do that, so they're actually intersecting all this irrigated agriculture, and we're going, what if irrigation changed? What if agriculture went away? This whole colony of 12,000 birds would just go away. Poof, it'd be gone because it has to have not only a place to nest, but food to eat. And so we're working with places like the Natural Resources Conservation Service that support agricultural producers to keep flood irrigated landscapes flooded around ibis colonies using this data. But we need more of this data because we only have 40 birds marked. We want to have 150 birds marked across the West to begin to inform conservation efforts like this, to put conservation dollars from that's coming from Washington out west to make irrigation practices more efficient. We want to make sure they're efficient, but also biologically kind of relevant to migratory water birds as well. Because we run the risk of actually making these things so efficient that the birds can't utilize them for food resources in the future. We don't want that. So to give you guys an example of how these things work, the way I do my research is what I call grassroots conservation. I usually get a small pot of money to start. My salary is paid. I'm a Ph.D. student as well. But I reach out to groups like Audubon chapters like yours, other state wildlife agencies, and other groups like the Friends of Mount Hero National Wildlife Refuge, and they crowdsource our funding essentially. And to date, we've raised about $100,000 worth of transmitters. Each transmitter costs about $1,300 to put on the back of a bird. And so these groups are helping us raise those funds to actually get things going. And part of tonight's talk at the end here is actually reaching out to you all as a chapter, and Travis has been very forthcoming and generous with this opportunity to kind of connect you guys with how you guys can help us by raising money or contributing money to this effort. Each transmitter, again, is $1,300. We're not asking for people to buy individual transmitters because we can take even small pots of money, because each year those birds, we have to buy them a new $60 cell phone, essentially, subscription to collect data. Even small amounts of money go a long way. But if you'd like to contribute to this, the best way to do that as an individual is to use the University of Montana Foundation account. And this is a way you can get to it with a QR code. I'm just going to pass over this for a second to go to actually the website. And this will bring you to the biology website. And you can read about the wildlife biology program. As you scroll down to the bottom here, there's a way for you to donate. And here you can choose a donation amount. You can put your own donation in. It'll ask you some questions relative to your name and who you are. And down at the bottom here, there's a way to put some comments in. If you'd like to donate here this way, just put in the comments, White-Faced Ibis Project. So we know the money you guys are donating gets set aside directly for this project, because all the money you guys donate, there'll be a small administrative fee just for people that handle the money, which is pretty minor. We'll go to purchasing transmitters or those cell phone packages we need for birds that are over a year old. We have to re-up their new cell phone package in the following year. But that's a great way for you guys to help if you're inspired by what you're seeing. If you really want to make a difference, we're all connected. Los Angeles and people there, the work you guys are doing, are just important as the folks in the Great Salt Lake, Sacramento, or in Missoula, Montana, because these birds experience ecosystems that span the continent. And having more birds marked in California, I will say, if you guys do provide dollars to us, we'll make sure they all go to birds in California. And you guys will be able to, at some point later this summer, to actually see the birds move around the state live using some of our apps. So I'll make sure I get those links to Travis so we can post those on the website. So if you guys sponsor a bird, if there's enough money to put a transmitter in circulation, you guys can follow that bird around the country and see where it ends up. Maybe it'll be in Baton Rouge, Louisiana. We don't know, or the Yucatan. But that is a way you guys can contribute if you feel like you'd like to do that. I'll also drop a link to this link in the chat too. Let's see. I'm not seeing the chat. Maybe Travis. I don't know. There's the chat. Sorry. I'll drop that link in the chat as well, if it lets me do it. Not letting me do it. While I'm doing that, are there any questions? I went through a lot of information. Anyone have any questions on things I went over or asked? Happy to answer as many as I can.
Just to start, I wanted to mention I did put into the chat the tool. You have the wet surface water version 23, and the API, some key on the API isn't working right now.
Yes.
So that, just so you know.
Yeah, we're actually in, the Department of Interior is negotiating the new contract with Google, which is the API and cloud-based computing platform I do all the modeling on. So it's going to be down for a few more days, but it'll pop back up again.
Great.
Yeah.
All right. Okay, so you can, folks, you can, if you have questions, maybe if you stop sharing, we'll see a few more faces and names. You can put questions in the chat and we'll grab them there, and or just go ahead and unmute and ask your questions there. There we go. And no need to be shy.
Do you guys get many ibis down in your part of the world on the coast? Do you see them cruising by at all? You don't see many, huh? No. How about avocets? Is that a bird you guys see quite a bit on the coast?
Yeah.
Sometimes?
Yep.
we're working on a project now to start marking avocets starting next year, and then there's new transmitters that only weigh 2.5 grams that allow us to put them on things as small as Wilson phalaropes. So we're going to get some more movements out of those birds as well. They're kind of super migrants. They end up down in South America in the wintertime and come all the way back to places like Great Salt Lake and parts of the Great Basin too, which are really important, through the Salton Sea and up through that Mono Lake kind of country in California.
Yeah. I was really interested about your capture technique for the ibises. Did you mean a spotlight or a strobe, a flashing light?
You can get a spotlight that's strobed, that's great, or if you don't, you can just kind of shake it and kind of strobe it on top of them. We didn't know how to catch them because no one had actually captured white-faced ibis before, so we were kind of at the point of having to figure out how to capture them, figuring out if the tags work right, how to attach them, and so we figured all that out last year. And you're up usually at 3 in the morning because you have to wait for the moon to go down if the moon's up. And you're out there tired and drinking coffee, and it's quite an adventure. At least it's warm. I'll say that. Capturing cranes, usually it's in the wintertime, you're cold. You're on land, but it's cold. Yeah, that's a little bit different. I could tell you guys some crane stories too if there's no question. Oh, looks like there's a question from Victoria. Is anyone following the effects on the GPS individual bird and how the GPS gear affects their health and well-being? So we don't have vets with us, but all of us are certified, permitted we're all U.S. Fish and Wildlife Service employees and biologists. And so bird health and safety is paramount to what we're doing. There's certain standards you have to meet for the weight of the transmitters. And they can't exceed a certain, I think with those guys, I think we're about 45% under the weight limit for the transmitters because the transmitters are so small and light for that size of a bird. And of the birds we marked, the mortality on these has been only one bird that actually hit a telephone line. It wasn't due to the transmitter itself. So we've been really, really successful. And not all birds respond that well to transmitters. Ibis are kind of a rock star. Cranes are rock stars. Most geese are kind of rock stars. You can put transmitters on them, and they'll go multiple years back and forth. And a lot of times the battery will kind of poop out or something will break before the bird does. And we think ibis are pretty long-lived birds as well. Cranes live, I mean, if you know, the cranes we're marking lived up to 50 years. They're really long-lived birds. Ibis are probably, I'm guessing, more in the 10, maybe to 12-year range. But we don't know. This is helping us understand how these things go. So yeah, it looks like, so wing mechanics are not affected, the GPS, no. The way we put the backpacks on, we use a cross keel technique. And so basically it'd be like if you were wearing a backpack while you were running and it was attached correctly, it'd be a little more weight, but you wouldn't impede your arm movement. We do the same thing with the backpacks so that when they're flying, it doesn't affect birds. And so we've had birds fly for 6 or 7 hours straight, point to point, with no effect. And the fact we have birds that are all the way in the Yucatan and flying back, telling us that the backpacks are not affecting their flight at all.
And maybe you could discuss whether you have to go through the animal care protocols of your university or just through the federal government.
Typically, if I was just a student, I'd have to go through the university. But because I'm permitted through the federal government and the Fish and Wildlife Service are the administrators of the Migratory Bird Treaty Act, that's a higher level of kind of, I guess, get an official stamp of approval than you would through university.
Yeah. And I'll just mention something about this topic is that we have literally decades and decades of experience of putting transmitters on birds. And one of the reasons I know this is that my father is a retired U.S. Fish and Wildlife Service biologist. And when I was in first grade, he came in to talk to the school and brought a radio transmitter that he was putting on black ducks in New England. and we played a little game of hide the transmitter in the classroom and triangulate with the, this is back when there was just radio transmitters, you had to triangulate where they were. But they have extensive information about the impacts and lack thereof of putting the of transmitters on birds. And I think there's, I'd be curious your thoughts on this, but you can never conclude that there's no impact whatsoever. But given the longevity and lack of apparent measurable impacts on flight and sort of social dynamics, all these sorts of things, the judgment has been made and made literally for decades on this data, that the data that you get outweighs the any potential impacts that are happening to the bird.
Yeah, we as biologists, you have to, and as managers of trust resources, migratory birds, the Fish and Wildlife manages as trust resources through the trilateral, through that agreement between Mexico, Canada, and us. It's our responsibility to maintain populations. And so by sometimes putting transmitters on birds, there'll be some effect. We mitigate all those effects, and we're getting so good at it now, those effects are really, really minimal. The habitat loss, based on the information we gain from those birds, and we're able to mitigate that loss, is far more valuable and ensures the long-term kind of viability of the population, which is our goal, and preserving ecosystems. And the birds, because they don't speak English, really help us do that using these transmitters. Let's see, Cindy has a question. Do the birds without transmitters ever shun the ones with transmitters? On ibis, no. Cranes, no. There is evidence that there's an impact on white pelicans. So white pelicans wear a small transmitter that goes on the horn of their bill. And if you put that transmitter on the horn of a pelican's bill, what we've noticed is another pelican won't pair bond with that bird, we think, because it's got the weird marking. So what we have to do is actually mark that in a way so it doesn't look like a little green tag, because you mark it with something so you can see the tag and know what bird was marked. So when you're doing visual observations with the GPS, you can actually confirm, oh, there's our marked GPS bird in that flock. Well, it'd be like one of us putting on a big mask or something and never being able to take it off and not getting a date because people thought you were weird because, your mask never came off. Same thing with pelicans. That's something we expect to happen. The birds live their whole lives, they're fine. It's just the reproductive prowess is diminished because they have a goofy face instead of, a normal one. Yeah. That was actually a really good question.
Wonderful. Well, I'm going to go ahead and end our presentation here that we're broadcasting over onto Facebook. We'll get that stopped here just a second. Thanks everyone there for attending and for watching it later on YouTube.